All right, well, welcome to our next video in our series, Introduction Coding Java. This next unit is about interfaces. It's a part of our classes and objects, unit. I would have a strong grasp on classes, objects, and inheritance before seeing this particular video. All right, so we've talked about how beneficial it is to have one class inherit from another if we have here, boy, I should probably switch the order of these. Let's see if I can do that. Nice. All right, so if I have here a superclass called animal and a subclass called cat, then anything that animal does, cat inherits, right? Cat inherits its fields, cat inherits its methods. It doesn't inherit its constructors, but we can make it so that we don't have to retype all the code. If animal and cat are going to be similar, I don't have to retype everything for it to appear in both an animal and in cat. I want to introduce a new idea, which is usually people ask, well, how many parents, how many things can you inherit from? And the answer is we can only ever inherit from one parent class. And that might sound disappointing, but if you find yourself wanting to map more behaviors from something else onto your class, then interfaces might be what you want. So what is an interface? It is a way of promising that the classes that implement that interface will define particular methods. So I want you to imagine that I'm making some finance software and I'm mapping everything in my home that costs money, right? The cat costs me money for food and vet care. My vehicle costs money when it breaks down, right? So everything that can generate money is going to be similar, or it's at least going to have a financial impact. But the problem is, if I wanted to make a helper class called vehicle, it would make no sense to say extends animal, because a vehicle is not an animal. It would make no sense to say extends cat. A vehicle is not a cat. So it's not that I want to copy paste everything from animal or everything from cat. I just think that any cat objects and any vehicle objects should be able to discuss how much they cost me in any given month. Well, the way to solve this is to go ahead and make an interface. So you'll notice there's this whole complicated list of things that we can make, and in the class, when I teach it, traditionally we're always just making classes. Sometimes you'll make yourself a text file for processing, right? Inputs and outputs. And then there's other things in here that are useful, but for the purposes of our course, the only other thing we're going to touch is called an interface. So I'm going to go ahead and name my interface, and I'm going to call this thing, oh gosh, maybe I should have considered this before I started the video. Let's call this costly, as in it generates a cost. Do I like that? It should be very nouny. So like cost generator. Yeah, that's probably a better name. Cost generator. And so anything that implements the cost generator interface should be able to produce how much money it costs to keep it up. So let's see what that looks like. Notice it's going to look familiar from a lot of the classes we've defined, but in many ways it looks kind of different, right? Instead of saying public class, we say public interface. And the way interface works is that we define but do not implement methods. And so here's what it looks like. You might say public double. I'm going to go with int just for simple math right now. Public int generate cost. And then I punctuate this sucker with a semicolon. Now, given how far in we are to introductory programming in Java, this is going to look pretty weird. You know, when we first learned methods, accidentally finishing our methods with a semicolon was a common mistake that we would make. And now here we are doing it on purpose. And the reason is I am only defining a method. It is not the interface's job to say how it's carried out. I'm just saying what that method header should be. And believe it or not, my interface here is done. So I'm going to go ahead and save it and put it down here. By the way, you can have an interface promise many methods. I'm just choosing to have it do one for right now. And so let's go down to the most open class that's ready for some work. Let's go to vehicle. I'm going to say public class vehicle implements cost generator. Implements cost generator. What that means is now this will no longer compile until I implement the methods that I've promised. So the best way, the traditional way that you will hear a programmer discuss an interface is that it is a promise or a contract to be fulfilled by whoever is, I agree, that does look wrong. Fulfilled? Oh boy. Fulfilled by whichever class is implementing it. And here we are. I said, all right, all vehicles generate a cost. It's not going to compile until I get that. So the method that I have to implement is called generate cost. So I'm going to do that. I'm going to say public int generate cost. According to the interface, there's no parameters, so I'll do that. And I'm just going to go ahead and say the monthly cost to maintain my car. Boy, I'm just going to pluck a number from my head between gas and insurance and wear and tear. $400? Boy, that's $300? I should go back and look at my Excel spreadsheet, but we're just going to use that number to start with. Okay. And now, check it out. It compiles, right? So when I say, what is this vehicle? I can say that a vehicle is, it's just a vehicle. It's not a cat. It's not an animal. But I can also now use that is-a relationship with, that doesn't work. I can use the is-a relationship with my interface. So I ask, hey, is a vehicle a cost generator? The answer is going to be yes. Yes, it is. So generic animals, I don't know how I don't even know what that looks like. I'm really only using animal for its subclasses. But I am going to go ahead and say that, yeah, cats have a monthly cost in my household for sure. So I'm going to ask that cat also implement this particular thing. So I'm going to say, if you ever want to have both a parent that you inherit from and an interface that you implement, you always go class, inheritance, then the interface. That's the order. It's always in that order. So I'm going to say public class cat extends animal implements cost generator. Cost generator. Okay. Now, this class doesn't want to compile until we define our own generate cost method. All right. Well, obviously, cats are going to be less expensive. So I'm going to say, whenever I ask a cat to generate its cost between food and vet care and whatnot, I'll say it's, $50, I guess. Just throwing that out there. Okay. So we do this, and you're thinking to yourself, the interfaces seem kind of stupid. I mean, if I want to have something that generates a cost, just have it generate a cost. I mean, I can define these methods. What benefit does it give me to be able to do this? It seems like we're going through a lot of trouble to try to link two classes together that generally aren't connected. And you would be right. Cat and vehicle have more that makes them different than they are similar. But here is the benefit. So just like we talked about subclass parking, we can do something called interface parking. And the way that interface parking works is I can say, all right, vehicle car equals, I just ruined the whole purpose. I'm going to say cost generator CG equals new car. And check this out. This compiles, why is it mad? Car cannot be resolved to, because I didn't, it's called vehicle. Nice, good. Okay, haven't lost my mind. Think about why this makes sense for a second. When we do subclass parking, like animal A equals new cat, then I'm allowed to put the cat in the animal spot because a cat is an animal. But we do know with subclass parking that when I do that, I restrict that object to only the behaviors approved by the spot. So what this means is that the only thing that CG can do is it can generate cost. Wow, and apparently of course, All the other things inherited by object, which is fine. But that's it. It can only generate cost. So you're thinking to yourself, Catherine, I need 2 more minutes, okay? Okay. All right, thank you. So you're thinking to yourself, why do I care about generating cost? Why is that good? Well, check this out. What if I made, this is really next level, so buckle up. What if I made an array of cost generators, right? So this would be, expensive things, or gosh, bills, costs. I'm going to call this costs. And it's going to be a new array of things that are cost generators. Here, I'm going to go and shrink this back. Cost generators. Maybe in my life there are, for the purposes of this exercise, there are 5 things that are cost generators. Okay. I'm just going to call these items, like line items in a budget. All right, so what I can do now is I can start, this paints a very bizarre image of my life. I promise this isn't really what it looks like. But I could say, items 0, let's put a vehicle there. And the reason I'm allowed to do this is because a vehicle is a cost generator. Let's go ahead and do this also with the second spot. And then I'm going to go ahead and say, in the third spot, which is index 2, I'll put in a cat. This is a truly bizarre scenario. I don't mean to suggest my life is only cars and cats. It is way more cats than it is cars. And I'm just going to cap this at 4 things right now. Okay, so here I've put vehicles and cats in this special array that is an array that's only for objects that implement this particular interface. And now you can probably see where I'm going with this. Maybe I make a int called budget that starts out at 0. And if I want to know what's the cost of my monthly budget, then I can go ahead and just go through all of these items. So everything that gets pulled out is a cost generator. I'll call it CG if I don't already have used that. Oh, I did. I will call it, these all things can just be cost. Okay, and we're pulling it out of the items collection. Okay. So then I'm going to say, all right, add to my budget. All of these cost generator items, they have a generate cost method that produces the int, that's the amount of, I guess actually I'll call it item. I feel like that maybe makes a little bit more sense. From the items array, pull out an individual item and then ask that item to generate its cost, add that to my budget. We go down here, we print out my budget, and if I did this right, $700, right? A couple of 300s and a couple of 50s, because that was the costs that I put in items. Okay, so to recap where we are right now, and we're going to add one more thing to it in a moment, the use of an interface is to promise one or more methods to 2 or more separate classes who you want to link together because they have a common behavior. You need them to do a similar thing. A great example is, rectangles and circles have more that is different than they do in common, probably. But you could ask both of them to find their area. So like area computable might be an interface that you make to connect the 2 of them. If you want to define multiple interfaces, you can do so. You just separate those with commas. So I could say comma space and add more interfaces there. That's another way that it's different than inheritance. And probably the most obvious way it's different in inheritance is that we don't actually provide the body of the method. It ends up just being a promise that we make so that perhaps that we could treat later on groups of things similarly because they all have this particular behavior that we like. The last thing I just want to tack on to the end of this presentation is you may have noticed it makes a lot of sense to make dog objects. It makes a lot of sense to make cat objects because we see dogs and cats running around in society. But what we don't see a lot of is generic animals. And what I mean by that is something that is an animal, but it is not a dog, and it is not a cat, and it is not a fish. It is only an animal. And what that means is if I'm never going to make an animal object, if I'm never going to say new animal, then perhaps it's in my best interest to make this class abstract. What that does is it puts a restriction on my code and says that I'm never allowed to make a new animal object. So if I say animal A equals new animal, now that it's abstract, it's going to complain and say, look, you can't construct something that is abstract, that doesn't work. So abstract is a keyword that means you can't instantiate it. Usually, if you have a superclass that's going to have a few subclasses, right, it's going to pass along its really good state and behavior to its subclasses, but you never want to make that class, and you want to make sure that you accidentally don't do that, right? You're going to protect yourself against making an animal object when you really didn't mean to. Abstract is a good way to protect yourself. Just like we use the word private to protect ourselves, we can use the word abstract to protect ourselves. So that's something to know. A class can be abstract. I will also throw out there that a method can be abstract. So we might say abstract public void speak, and then we just slap a semicolon on this guy. And the reason I teach abstract in this same particular video is this bizarre semicolon technique should look pretty similar. Just like we put a semicolon at the end of the method that we promised in the interface, so too can we just define an abstract method in animal. And it has a somewhat similar effect where it says, all right, look, I'm not going to define speak because I'm a generic animal. It would make no sense for me to define what it is that I say. However, all of my children need to have this method. It needs to be this return type, this kind of access, and they need to define it. And sure enough, we see now it says the cat type must implement the inherited abstract method animal.speak. All right, so in summary, interfaces are like inheritance, but we can have many interfaces inherit from only one superclass. When we inherit, we get the code. When we implement an interface, we do not. And the abstract keyword can be used to make it so that we cannot instantiate an object, protecting ourselves. We can use the abstract keyword to promise that our children will implement a method that we ourselves don't want to implement. Whew. Thanks for hanging in there. Thanks for watching. We'll see you next time.